In the great desolation of space, beyond the shroud of the familiar, a star shines gently in the south constellation of Musca. It is HD 100,546, a star but more, a cradle in space. A ring of dust and fire, untamed and uncontrolled, roams around it. And within this dazzling nursery, a planet is formed. We journey 320 light-years from planet Earth, away from city streetlights and ocean tides, to observe creation in the process. Hello, HD 100,546b, a giant gaseous world in its fiery youth. Larger than Jupiter, perhaps nearly 7 times as big, it storms in a hazy orbit, radiating in infrared as it accretes material onto its growing hub. Imagine in your mind's eye Jupiter not as the mature, tranquil giant we know, but as a turbulent, radiant baby, still gathering the raw stuff of moons and rings. Near HD 100,546, the protoplanetary disk is a masterpiece of motion and shape. Spirals sweep across the universe like cosmic whirlpools. Gaps bisect dark bands in the dust, as if unseen artists have plowed matter aside to create the outline of future worlds. Tighter clumps of gas imply hidden siblings, other planets still in the birth disk's womb. Each feature tells a story of gravity's relentless dance, of matter pulled and pushed, unraveling and reforming in an endless cycle. A smaller disk can envelop HD 100,546, be itself a ring about the planet in which new moons begin to grow. Within this smaller whirlpool of material, ice and rock moons can coalesce, circling the giant planet in just the same way that our Galilean moons orbit Jupiter. We glimpse the formation of moons, the seeds of new worlds swirling in dusty arcs before they coalesce into solid worlds. Our eyes on this distant cradle are the world's most capable telescopes. In Chile's Atacama Desert, the Very Large Telescope uses adaptive optics to eliminate Earth's blurring atmosphere and reveals fine structure in the disk. High above our heads, Hubble gathers light scattered by tiny grains of dust, and infrared instruments detect the heat glow of the planet forming itself. Polarization filters select out the grain orientation, charting magnetic fields and currents. It's by these complementary methods that we construct the image of a planet-forming world in the making. But HD 100,546b is confounding our theories of how planets are born. Classic models picture a slow accretion of gas onto a solid core, a gradual build-up over millions of years. Here we also see something more violent, shocks and oscillations ruffling the disk, gravitational instabilities causing blobs of gas to collapse almost instantly, and spiral density waves painting the disk with moving patterns. It may thus indicate that planets can come into being fitfully, in fits and starts, with periods of fast growth punctuated by quiescent phases. Turn to the analogs in our solar system. Billions of years ago, Jupiter and Saturn meandered in an original disk, clearing out gaps and creating turmoil. Their migrations may have flung asteroids inwards, defined the asteroid belt, and even impacted Earth's water supply. Observing HD 100,546 lets us glimpse those lost ancient dynamics, a shadow of our origins, acted out again on a greater scale. The farther down we probe, the more questions arise. How many worlds share this star? Do there exist Earth-sized rocky worlds lurking inward, obscured by the dust's glare? Might some have already cut their lanes, leaving narrow channels waiting to be found by the next generation telescopes? ALMA's radio antennae have started to distinguish finer detail, picking up cold rings of dust that suggest other planets cutting their paths. Looking ahead, the James Webb Space Telescope and its infrared instruments will pierce the inner disk, mapping temperature variations and chemical signatures. We'll search for water vapor, organic molecules, and the hallmarks of complex chemistry. Each detection brings us closer to understanding not just how planets form, but how they acquire the ingredients for life. Take a moment to reflect on the scale of time and space. Light from HD 100,546 left its star centuries ago, long before our pandemic-locked world existed. We see its present form as it was in the past. reminding us that astronomy is always a dialogue with the past. Yet, while we look, we see change, the planet radiating warmer here, a spiral arm glowing there, a gap slowly widening. The universe is alive in motion even when we perceive it as stationary. It also speaks to our place in the universe. We imagine planets as fixed objects in the evening sky: Earth, Mars, Venus, each with its history. But out there, planets are giving birth every day, in millions of nurseries across the galaxy. Star for star, disk for disk, the Milky Way teems with creation events, each with its drama, its chemistry, its potential for complexity, and perhaps even life. This is what a world around a star like HD 100,546 would be like. The disk retains residual heat, radiation intensities are high, and if rocky planets form enclosed, they would be baked or bombarded. But further out, in the cooler zones, icy bodies may accrete volatiles, the seeds of prebiotic chemistry. And so again, the reminder that the cradle of life can differ greatly. Some worlds will emerge in tranquility, others in turmoil. The ground-based extreme precision spectrographs will scan for those subtle wobbles in a star's motion in the coming decades to find those planets to dim to image directly. Space missions dedicated to starshade technology can potentially block starlight directly to expose small worlds within the light. With each turn, our arsenal expands, honing attention to these faraway nurseries. Yet technology itself is not enough to tap the poetry of creation. As writers, we must weave facts into fiction, make tough statistics into images that touch the heart. Picture yourself drifting in a spaceship, gliding along the inner edge of the disk. You drift past enormous dust grains glowing orange in the starlight, whirl through tunnels of frozen particles reflecting pale blue glints. Before us, HD 100,546b glows as a red warmth, jets of incandescent gas streaming from its poles, circumplanetary rings churning around its equator. There, science becomes art, and art brings back wonder to science. We remember why we gaze up. Not just to take an inventory of worlds, but to understand the large-scale mechanisms that mold them and, in the process, to learn more about our little blue world. As the final act approaches, let music swell. Show the disc intact, embossed with all of its spirals, slashes, and rings. Make HD 100,546b shine brightly at its center, a beacon of formation. And then step back to reveal the Milky Way sweeping out above, a braid of stars and dust, every point a potential cradle for new worlds. Today, posting this story in daylight hours on our home planet, we invite our readers to carry into their day this cosmic perspective that creation comes on titanic scales, out of sight and yet continuous. That our planet is just one of billions, and that in the depths of darkness in space new suns and planets continue to materialize. Let this pilgrimage to HD 100,546 awaken your awe. For whenever we lift our eyes, we behold a universe eternally in motion, planets birthing, stars burning into life, and time unwinding in the universal drama of eternity.